Hi, I'm Geoff Nicol. Myself and Stewart Lord are both technical architects on Perforce Swarm, and we're going to be talking about how to do effective code review and how to alienate your coworkers. It's an exciting opportunity to be able to share some of our own experiences on code review with such a broad audience, and we're quite hopeful that you'll be able to take away some real key insights from it.
Thank you so much for coming to this talk. Actually, that's awesome. Good turnout. I know there's like 4 tracks and so many great talks to pick from, so we really appreciate you guys showing up to hear us blabber on. I'm Stu.
I'm Geoff.
We're both architecty, software architecty people, and as Mark said, we're the lead architects on the Swarm project. So we've got a bit of experience doing code review. As we developed Swarm, we learned lots about code review, and even before that, we did code review on previous projects, and that's actually one of the reasons why we started down the path of doing Swarm. So this is a pretty short time slot. We got 30 minutes. We're just going to rip through this. It's going to be fun. It's going to go quick. But I wanted to give you guys a bit of an idea about what we're going to talk about and how we're going to go through this. So let's just dive right into it. The first thing we're going to talk about is why do code review? You may have this idea that it's a burdensome process, and we're going to try to shake that out of you. Next thing we're going to talk about is our philosophy. We're both developers. We're pretty technically minded people. So we come at code review with maybe a slightly different perspective than some of you guys in the audience. And we're going to speak to that a little bit. So you'll see what I'm talking about in a minute. Next, Geoff is going to do a deep dive into nitty-gritty about how we approach code review. He's broken it down into 3 simple steps, and he's going to take you through that. And then the last section, the last section with any substance is it's just a bunch of stuff we wanted to talk about, but we didn't really know where else to put it. So bonus round, we're going to give you some more information. And then if there's time, I'm sure there'll be time, we'll do some questions. So why do code review? This is probably a good time to take a poll. You got to do a poll, right?
Definitely.
At the beginning, get everybody excited. So if you currently do code review on your team, your projects, any forum, please put up your hand. Well, that's amazing. That's like everybody pretty much in the room. So I think we're safe to go with the second question.
Yes.
Do you want to do it or should I?
Oh, I thought you had it.
Okay. If you don't do code review, please leave. All right, we're kidding. That's good. That's great to see everybody doing code review. Code review is awesome. So why do code review? I think that the big goal, the obvious reason to do code review is because we want to build a better product. That's what it comes down to. And I think when we're writing software, there's this inescapable fact that bugs are going to happen. So you have a choice. You can find those bugs early on, or you can find them later. If you find them early on using techniques like code review, unit testing, all that good stuff, then you're going to save money. If you find them later on, once you've shipped the product to the customer, it's a lot harder because you have to diagnose the problem, which is tricky because it's at arm's length. You've got to get a patch to them. And at that point, you've already done some damage to the customer, to your reputation in the customer's eyes, right? Mm-hmm. So fixing bugs early is really good. You've got your choice, do it early. And then it might not be obvious, particularly if you actually read the title of our talk. But in our experience, doing code review actually builds a stronger team. We found that just being able to get together and put your heads together, learn how other people approach problems, and bounce ideas back and forth through the process of code review is really helpful. It gets everybody pulling in the same direction, like if you're rowing a boat, in a big team. Geoff does, what's that called?
Paddling.
Dragon boat. Does dragon boat paddling. And so the idea is, you all want to be going in the same direction, the same pace, and towards the same goal. And code review is one way to do that. There's lots of ways, but it's an effective technique for that. The bottom line, though, is that it's one of those rare cases where it's something that's pretty cheap, it's really effective, it's really good, and it doesn't take a lot of time, it's fast. So yeah, you should, you're all doing code review, but...
Well, and the fast is good to qualify as well. Like, obviously, the review process takes some measure of time.
But
Yeah.
I think in our experience, like by finding these bugs earlier, the time savings you get with the customer like more than pays that. So it's like it does take time, but
Yeah.
overall you come out way ahead.
Yeah, and that comes down to that choice. You know, whether you want to do it now or you want to do it later when the customer's already seen how you suck at writing software.
Yeah, it's better if it's a surprise.
So we have some statistics. We've got some mind-numbing stats for you here. These come from a book.
You can see the
Oh, yeah, it's down here. That's easier for me. Thank you. It's called Code Complete by Steve McConnell. And so we got 3 stats here. JPL, that's the Jet Propulsion Laboratories. Pretty fancy guys. They estimate they save 25 grand per inspection. They're building jets, though. So, I mean, actually, we do have some pretty significant companies in Perforce. Maybe you guys are building jets or airplanes or something. But so your mileage may vary, but the idea is that if they catch it early, they're saving money.
And they attributed that actually directly to catching those bugs earlier in the process.
Finding and fixing the defects, yeah, before they shipped it was the key. That next stat, 55 to 60% defect detection rate. So that is, I'm going to contrast that for you with other means of catching defects. So from this book, unit testing caught 25% of defects, and integration testing caught 45% of defects. So I was actually surprised. I didn't really think, I mean, code review is great, but I didn't think it was going to be quite that good. 55 to 60% defect detection rate sounds great to me.
Mm-hmm. Yeah, when it's surprising too, because like we love unit tests, like we still encourage them and they're great, but it's surprising comparatively how much difference there is.
Yeah, I mean, you hear so much about unit, everybody's doing automated tests. You've got to be doing automated tests, and we are, and I'm sure you all are. But you don't hear this kind of information, and maybe that's, maybe that's a one-off, maybe it's
That's
totally
the
bogus.
incredible value we bring.
Yeah, that's right. I mean, it could be total BS, but it's a good thing. And then this last one is from a study at AT&T. They had 200 software developers, and then they looked at their process before they did code review, and then they looked at it after they did code review, and they found they were 14% more productive and 90% fewer defects. A bit about philosophy. As I said, we're technical people, so we may have a slightly different definition of code review than you guys. What we want to get you to do here, think about, is broadening your definition of code review. If you go back to why we're doing it, the goal is to build a better product. It's not to build the most fantastic code that nobody sees. It's to build the best product that your customers can use. So with that in mind, that leads into a quote. I picked this quote off Twitter. Thomas Fuchs, he's a JavaScript guy, sort of internet famous software guy. And the leading part of the quote is, your job as a developer is to optimize user happiness to lines of code ratio. And I read that months ago, and I was just like, wow, I absolutely agree with that. That totally resonates with me. I mean, that is, I think, what's important, because we can spend a lot of time finessing white space, which we do, and writing these beautiful algorithms. But at the end of the day, it's about a product that users are using. And so we really want to optimize for that, and code review is a great way to do that. A few key things that are going to back up the steps Geoff's about to tell you about is this idea of getting quality built in ideally before you commit. You can do post-commit review, but we really advocate for pre-commit. Before you get it into trunk, master, whatever you want to call it, check the quality via code review.
And that's a good clarification. Like commonly you might commit to a task branch or a software branch. Like that's fine, but really before it makes it into main or master.
Mm-hmm. And then it follows from the quote, but we want to deliver the best UX possible. Use code review as an opportunity to do that. You probably got a UX team and they've given you mock-ups and everything and you're building according to spec, but do a gut check. And then lastly, learn from each other. Build a stronger team because of it. Use it as an opportunity to work closely with your peers and elevate the level of the entire team. You know, I constantly learn new things from Geoff. Probably less often he learns things from me. But also if you have maybe more junior members on your team, code review and particularly pair programming, which we're not really talking about here today, are great ways to bring up that level. You had an interesting study or something you had?
Yeah, there was a note on an episode of This American Life, and they were saying when you're looking at like a variety of teams and you're wondering to yourself like which of these teams are likely to be successful and which ones are likely to fail, you might naively think the teams with like the best people. I just look and find the team with the best person. That's going to be the winner. And that's not actually the case. It's the kind of average skill level on the team. That's what determines if they'll be successful or not. And so when you have a fortunate situation of having teams with good people on them, making sure you're kind of like taking that opportunity to share that knowledge and bring up the average level really boosts your chances of success.
It's like the socialism of software development.
To each according to their ability, I suppose. On the best UX possible and learn from each other notes as well, like code review can be a process. It's like broader than just the developers as well. Like QA and UX can actually be actively engaged in the review process.
sure.
They can be looking at the review, commenting on it, really be in there.
Yeah, and we'll talk about that more a little bit.
Well, then I got ahead of it.
It's your turn.
Woo.
Give her.
So I want to talk to you about the 3 key steps we see making up code review. We don't really use like a formal checklist and go through these, but it's just a bit of a guideline or a guiding principle that we actually met as an overall team and tried to just qualify a bit. How does this process work the best for us? So just to give you an intro to what those steps are, at a high level, we want to start by really stepping away from the code. As developers, our first instinct's commonly like, let's just dive right into the code and look at it. That's our part. But there's a number of things you really want to think about ahead of time that are going to impact the code. And if you skip over them, you're just going to end up reviewing things that change. So the first step is to step back, and we'll look at what that means. Once you've done that, you actually still don't want to look at the code. There's a few more things to consider, like about the experience and using it. And then lastly, once you've gotten through both those phases, then you really want to look at the code. We actually had an interesting interaction with a customer recently. They were saying, like, I did a code review, I had a trigger update in a Perl script, and I had like 4 people, and I was like, oh, thumbs up. And then I put it into production and it blew up. Like, why'd I even bother? And this comes down, I think, in part to step 3. Like, it's a real effort to look at it properly, but you have to do it. So when we say step away, what sort of things are we talking about? So at this early phase, I've like pulled up a review from a coworker, and I think I really have to ask myself, is this the review I should be looking at? Like, there's probably a pretty big backlog of reviews I could be doing, jobs I could be working on. So when I assess one, I want to know, like, do we know enough? You often hear from the customer, like, oh, add this feature. What you really want to know is like, well, why do you want that feature added? What are you trying to solve? And let's make sure we understand the real problem so we're actually solving it in the best, most generic way. So we want to make sure we kind of have a good enough feel about it. Usually you will, so you move on. Even in this early phase, you might have a vibe on, maybe this is too big. Like, I'm looking at this, I haven't looked at the code yet, but I can see there's a lot of files. Like, this looks scary. I don't really want to review this.
Yeah.
So
I think this ties into something that, for you guys that were at Jez Humble's talk yesterday, he was saying about the risk that comes with using feature branches. And I don't know if it's so much that he hates feature branches or task branches, but I think it's that he hates the divergence. So if you create some big, massive monstrosity and you're all the way away from main or master or whatever, and you don't come back or you don't break it up, then that's where you get your monster merge problem.
Yeah, and there's a real tax off developing that way. So like, you're burning a lot of effort, and as a reviewer, you just can't do as good a job reviewing something gigantic. It's just not really possible.
Yeah, so break it up.
Yeah, and that just generally means maybe pick some baby steps to increment towards it. It's also a good time, and you want to think about this through the whole process, but to start considering and percolating a bit on what could be the side effects of this change. Should I be filing some doc jobs? Should I give QA a heads up? This might be tricky because it involves integrating. Just what other things might be impacted by doing this? And on a related note, like, how's this fit on the roadmap? If you're an agile shop, your roadmap might change over time. Maybe this was a high priority before, but now it's actually not. I'd be better served elsewhere. So reassessing that sort of thing as you go along. Another point for us is the release cycle. We're really keen on dog fooding our product. We like to use it ourselves and really experience it to make sure that, like, you have the plan on the paper, you implement it, and then you actually use it for a bit and you make sure it is pleasant to use, that you have shaken all the bugs out of it. So if it's a particularly large feature, we prefer to put it in like earlier in the release cycle so it's got some time to bake. And then smaller features can sort of trickle in towards the end. So it's not a huge goal, but like taking that into mind to a degree is helpful. So now that you've sort of considered the feature you're looking at, you've told, yep, this is like a reasonable thing to be working on. We know enough about it. It doesn't look scary big. You still don't want to jump into looking at the code yet. You really want to start with the user experience of it. So ideally, you'd get a copy of the program or the web app or what have you that's actually running this proposed modification. And you just poke at it. You like, how closely does it match the wireframe plan we had? How does it actually feel to use? Is it glitchy? Is it smooth? And now that I actually can click on it and interact with it when the rubber's met the road, like, is it actually pleasant? Does this make sense? Maybe we want to get UX in the loop and chat about some error conditions or side effects or how it actually is to use.
Tricky too, because a lot of time people view software development as a pipeline with, it goes through this stage, it goes through the life cycle of it, right? UX, dev, QA. But I think if we can get more to the part where we're all working together and we're iterating on it, code review is a great place to actually have that happen, get everybody together looking at it.
It's really more like feature review. It's not just the code.
And I'm checking the time.
Yeah, there's not much of it.
Yeah.
I'll talk faster. So aesthetics are important. We really want it to not only flow smoothly, but we want it to look nice and also look kind of consistent with the rest of the application. So this is another opportunity. Maybe the plan was for it to look nice, but does the implementation execute on it? Are things lined up correctly? Does it have a good look? You may find you're working on something where there is no UX, it's not a visible feature. Oftentimes those involve some sort of an API. Either you're talking to an external one to consume something, or you're producing a new one so you can expose things to the other users. In those cases, really looking at the API, because you want to have a feel of the background context you're in. The way this is being implemented, does it meet with the surrounding API? Is there already something else that does what you're trying to do? And if you're consuming an API, having some background knowledge on what are its capabilities and its approach, so you can give good feedback on whether or not what they're attempting to do makes sense. And that all kind of just relates to looking at the context. So after we've gotten all the way through this process, we know we want to be doing this thing. It's a good priority. We understand it. We like how it feels to use. We can understand the context it lives in. It's attractive. Now is a good time to look at the code. And a good thing to reflect on momentarily is, if you look at what those steps are we just went through, particularly how it feels to use, if you find things in those phases, which we commonly do, when you make modifications to them, this is going to flux the code, often quite heavily. And so if you'd started with the code, you probably would have wasted a lot of time. It's better to kind of have it bake out a bit and then get into that level.
It can be hard to see those things when you're really deep in the code. So sometimes you have to step back to actually see those bigger picture issues.
So because this one's a bit trickier, we broke into two kind of arbitrary chunks. The first phase is to kind of look at the logic of the code. So this relates to just really inspecting that code line by line. Every changed, added, deleted line, that's kind of a liability in the code. That's a real opportunity to introduce a bug. So you want to be looking at going I want to understand, why was this line added? What's it doing? Why did you change that? And if I don't know, that's kind of a problem. I should figure it out or ask you, or maybe that's an indication that it's not well coded because it's unclear. But you have to really force yourself to look through it. As you're doing that, striving for simplicity, maintainability, when you're approaching this as a reviewer with fresh eyes, it's a good opportunity to get a vibe on how intimidating is this code to parse. If you're having a hard time jumping into it, you can probably power through it, talk to the person who wrote it, but when you come back in a year to maintain it, you're going to have that problem again. So try and really take this opportunity to simplify it. Two different slants on the same basic idea are to consider edge cases. Commonly if you're dealing with a string, you might be kind of off by one errors. If you're looping, kind of the beginning and endings are commonly a problem. So just looking for things like endless recursion, basic logic errors, edge cases are commonly a fun spot to find those. That's obviously pretty good. And then the other one, having a security slant that I like to do, is just to kind of look at the method as if my mission in life is to cause that method's suffering. If I was an attacker, probably from a security standpoint, but maybe just from it being a jerk standpoint, what sorts of terrible things would I send to that method? Maybe overly long encoded UTF-8, really large inputs, attempting to do things like SQL injection or other security problems, and just really cycle through how would that deal with these situations. So just trying to harden the code. The second phase of it is to kind of really look at the finesse of the code. It relates to the simplification, and we're trying to balance these things for readability. We say somewhat conflicting things, every line's a liability. Oh, well, let's just put it all on one line and use semicolons. The readability is a higher priority. It needs to be as simple as it can be and no simpler. It needs to be readable.
There's that saying about how you should always write your code. Always write your code as though the person who ends up maintaining it is a violent psychopath or something who knows where you live.
Yeah.
So maintainability is super important.
Well, it's easier for you. You don't have to pretend. The commenting is also very important in code, and in both directions. A lot of people, particularly newer developers, tend to actually over-comment code, and then the comments just become white noise. You don't really read them anymore. But well-commented code is important. Commonly, that means telling me why you're doing something, not necessarily what you're doing. Hopefully, I can look at the code and see what you're doing, I might not know, based on my limited context, why the heck you're doing it. So those can be useful comments. Also, if you have a big block of code, a big case statement, something longer, in that case, giving me a little overview of like what you're trying to do at a high level can actually be quite helpful to skim through it. They say, you know, two of the most difficult problems in computer science are cache invalidation and naming. And as you're going through the code, just really considering for the variables, the method names, the constants, like are these good, clear names? When I first approach this, do they resonate with me? Can I understand what they're doing? Are they misleading me? Commonly, you like get the wrong vibe off of them. Putting a bit of effort up front into the naming, it's not going to necessarily innately eliminate bugs, but that clarity can help you find bugs you would have missed, and it'll certainly help you maintain the code later.
Bonus round time.
Oh,
Do I have my sound effect?
I think so.
All right.
This is elegant. The delay makes it better. I don't think that's the right sound effect.
All right. It's appropriate because we've only got like 6 minutes. So bonus round, random things. Ensure your code has tests. Code review is really important. Testing is very important as well. So at the code review stage, don't give your coworkers a pass, maybe. Suggest they have tests if they don't have them. And to take it one step further, you know, any good code review system is going to be able to integrate with your Jenkins or your CI system. So, you know, whether it's Swarm or, you know, GitHub with Travis CI or Garrett or whatever, you're going to get a red or a green light if you hook it up correctly. And that's going to let you know as a reviewer whether it's even worth your time diving into this code. If the tests are failing, push it back on the author. Make them fix the tests. Something that is a little less common but is available in Swarm is the ability to integrate with the staging environment. And this we've actually found is super useful. So the idea is that on a given code review, there's a button you can press that lets you try it out. So that may mean it's a binary that you download and you run locally. It may mean it's taking you off to a staging server that's synced that code down. But the idea is that you can very quickly see how that code functions in a simulated environment. And that saves you a lot of time because, well, for one, you might be UX or QA and you might not have that dev environment set up. But also, maybe you're just a lazy developer and you don't feel like reconfiguring your workspace because you're in the midst of something. So integrating with staging is actually really cool. And we hope to see more people doing that. This point here about pair programming is just that we're both fans of pair programming. And I think of code review as like an asynchronous form of pair programming. You get a lot of the same benefits, not all of them, but you get it with a little bit less time because as a senior, you can juggle perhaps 3 or 4 code reviews at a time, whereas if you're pair programming, you know, you're sitting at that person's desk, and there's a time and a place for that. So both are great.
I found particularly on like the more difficult problems, you can just end up getting kind of blocked on them. They seem a bit overwhelming. And in that case, pair programming is great because it just forces you to kind of power through them, and the two heads, you can kind of overcome the problems quicker. On the easy to moderate things, it's not, in my experience, the best fit.
For sure. The last point is about contributor guidelines. If you want to set up some rules around how code review is done in your organization or for a particular project, take a look at some popular open source projects. And the larger ones will have contributor guidelines. And they outline things to watch for, like coding standards, how to pick an issue out of the issue tracker that's appropriate, that they're accepting requests for. And that can all be great inspiration for developing your own guidelines.
So you may have noticed at the beginning, we did promise to give you some info on how to alienate your coworkers. And I'd say like Stu's speciality is more the code review. Mine would be in the alienation. Unfortunately, I think it was kind of just a hoax to get more people in the room. I think a lot of folks do realize, though, that like team dynamic, coworker alienation, it feels like a real risk with something like code review. Like a lot of people don't necessarily feel comfortable with other folks giving them feedback on what they're doing. And I think there's a few ways that you can sort of try and talk with your team and make that less of a problem. One of them, I think, is understanding why code review is valuable, what you're getting out of it, which we've tried to cover a bit. Another big one is just to try and sort of check your ego at the door a bit on it, like realize that we're all going to make mistakes. We're just trying to make the product better by doing this process. And also like how you go about it to a degree, perhaps when you look at it, and I think Stu may have suffered a mild stroke when I look at his code. I'll probably just directly observe that, but if I was more thoughtful, I could say like, why did you do it that way?
Why did you suffer a stroke?
And many times they may well have a really good reason and you just don't know the context on it. So sort of assuming the best on both sides of the conversation is helpful. Iterating is very helpful when you jump onto a review and there's just like so much wrong with it. Maybe it's a new person or it's a really complex problem. Don't necessarily identify every single problem on the first round. Like pick off some high points, let them fix them, they rev it, you come back, you give some more feedback, you iterate a bit more. It's actually easier for them to absorb the input, and it's easier for you to check their changes to see if they've addressed them or not. One thing we have a note of is try again. We actually find occasionally you'll get a ways in on developing a feature. It's in review, it might even be a ways along, and you're looking at it and you're trying to give feedback on how to make it better, and it just seems like we went down the wrong path. This just isn't working. It's not a tweaky thing to get this right. And so you might want to consider even like launching a second review and just taking a totally different tack on the problem. It might be worth backing up and trying it over again.
We've certainly done that a number of times.
It's happened a fair bit, and particularly if the feature is like something important or will have a big stability impact. And then just having like a bit of a lighthearted attitude about it, using GIFs, emojis, memes, YouTube videos in your comments can be somewhat entertaining. Everybody likes a good cat picture.
Yeah, I think that's basically it.
Hey, let's give Stu and Geoff a big hand.
Thank you.